Welcome to Winsome Mathematics. So this is another video related to the relation between beta and gamma. So what will we do here? That we will prove this relation. So why? So we will discuss it. So first of all, you haven't watched the video concerning beta and gamma. So please check the description link is provided and must watch it to be more familiar with this topic. Okay. So now let's come to the topic without wasting any time. So this is the integral given here. Okay, simple, and we have to prove it. This is LHS and this is RHS. So why are we proving it? So this is the first question. So simply we know that whenever we come across, like in previous video, in the example of 0 to the same example here, 0 to pi by 2. Okay, 0 to pi by 2, 2 cos 4 theta, sine 6 or 7, probably 6. Okay, 6 theta d theta. So we always need to compare it with 2m minus 1, this with 2n minus 1. So just to remove this obstacle, so down to compare it regularly. Okay, so we need to derive this formula, like we can simply write 4 plus 1 by 2, 6 plus 1 by 2, and this is 4 plus 6 plus 2 upon 2. This is more convenient. Okay, simply, so this is mandatory. Okay, so must prove it. Okay, so this is our needs. So needs is very clear. Okay, so now we will see the proof of this definition, or you can also say the property. So now proof. So how to prove it? So simply not any obstacles. Okay, so this is the most simple proof. Just we know that beta mn is equal to gamma n upon gamma m plus n. Simple. This is our first relation, and we know the definition of beta mn, that is 0 to pi by 2 sine 2m minus 1 theta cos 2n minus 1 theta d theta, and this is equal to 2 into 0 to pi by 2. Okay, so must remember the limits, and whenever 0 to pi by 2 comes, we use the term sine and cos. Simple. And this is equal to gamma n upon gamma n plus n. Okay, so what are we changing? Simple, just remember one term. Okay, one thing, just remember that replacing 2m minus 1 by p and replacing 2n minus 1 by q. Why are we replacing? Because we need to do it. We are having to do it. We were having to do it in the questions, in the previous question, cos 4 theta, sin 6 theta, because we always compare 4 with. So not to compare, just because we are proving it. So simply the step is clear. Just to remove 2m minus 1 with p. So we are comparing. Simple. Just so m is equal to what? P plus 1 by 2. Okay, n is equal to q plus 1 by 2. No any problem. So you can easily write it 2. So first 0 to pi by 2 sine p theta, and this is cos q theta, and m is replaced with p plus 1 by 2 and q is replaced with q plus 1 by 2. So what is m? M is p plus 1 by 2 and this is q plus 1 by 2, and this 2 will come here, and m plus n is equal to p plus q plus 1 plus 1, that is 2 upon 2. Simple. So whenever the questions will be given directly in the form of sine and cos, so you can simply use p plus 1 by 2, q plus 1 by 2, where power is p and power is q in of cos, and you can change because it's constant, so power is q, p doesn't matter. Okay, so simple, we have to do power plus 1 upon 2, power plus 1 upon 2, and 2 into power plus 2 upon 2. So clear? So this was the importance, and this was a very simple proof and simplest proof. Okay, so now we will see some examples based on it. Okay, so after this we will see all the questions of beta and gamma, and after that we will see the duplication formula, then we will also see the questions of duplication formula, then our chapter will be finished. Okay, so we can write, so now examples. So these are the some examples based on this formula. Okay, so how will you solve it? Simple. This is very simple. Just we have to, this is the problem here. What? We are not observing the term of sine. So what we had done? We have learnt it. Okay, so what we had done, simply we need to implement the term of sine. So this is multiplied with 1. So how to transform 1 here? So simply we will do sine 0 theta. Clear? So this is the simple thing that we have to implement here, that this is cos 7 theta. Okay, and this is sine 0 theta. You can easily write it. Okay, sine to the power 0. Okay, sine theta to the power 0. This will look more clear, okay, and comfortable for me, and for you can also write sine 0 theta. Doesn't matter. Here you can easily, what we have to do, just simply we have to traverse it here. 5 plus 1 by 2, that is gamma 5 plus 1 by 2. This is gamma 3 plus 1 by 2, and this is what, 2 into 5 plus 3, that is 8 plus 2. Simply we will write it 5 plus 3 plus 2 upon 2, that is 8 plus 2, 10 upon 2, that is 5. We can easily write it 2 gamma 5. Now this is what, 6 by 2, this is 4 by 2, so this is gamma 3, and this is gamma 2. And what is here, this is 7 plus 1 by 2. I have done this before because you might uh, be strange with 0. So this is not a problem. 0 is also 0 plus 1 by 2. That is gamma 1 by 2. So 7 plus 1 by 2, gamma 0 plus 1 by 2, and gamma 7 plus 0 plus 2 upon 2. Clear? So we can write it 8 by 2, that is 4. We can write it gamma 4 and gamma 1 by 2, and this is gamma 2 into gamma 9 by 2. Simple. This is easy. And what will we do here? So we will discuss it. So how to, first our motive is to transform it in the definition of beta mn, which is related with sine cos. So how will we convert tan in sine and cos? And we have been doing it since childhood. Okay, so simple, we will do sine theta upon cos theta. So we can easily write it. So we will see it here. So first we will calculate it simply. So for more space, that is 3 factorial, and this is root pi. Okay, and this is 2 into gamma 9 by 2, and you can solve it with recurrence relation, that 7 by 2 plus 1, so gamma 7 by 2, gamma 7 by 2, further 7 by 2 into 5 by 2, gamma 5 by 2, 7 by 2 into 5 by 2 into 3 by 2, gamma 5, 3 by 2, again 3 by 2 into 1 by 2, gamma 1 by 2. So root pi will be cancelled with root pi, and all the constant you can easily multiply. So this is more simple. This is 2 factorial, this is 1, gamma 2 is equal to 1, 2 factorial cancelled with 2 factorial, 1 upon 4 factorial, because gamma 5, so 1 upon, what is 4 factorial, 24. Okay, so here we will see these two questions. Okay, because this is also really similar to these questions. Okay, so must solve it independently, and I will tell you to solve this also independently. After, must watch the solution. So how to transform it? Uh, Root under tan theta, that is sine 1 by 2 theta. Clear? Cos minus 1 by 2 theta, because cos is in the denominator. Cos is in the denominator. So we can easily write it 0 to pi by 2 d theta. Okay, and this is 1 by 2 plus 1, 1 minus 1 by 2 plus 1, again this is p, this is q. So simple, you can write. So this was the main concept here. So how to transform it? Okay, so simply this was simple, most simplest thing, but doesn't click at once. So please remember it. Okay, that how to transform tan here. Okay, so now gamma 1 by 2 plus 1, and here minus 1 by 2 plus 1 upon 2 here minus 1 by 2 plus 1 by 2, that is 0, 0 plus 2 upon 2, that is 1. So simple, no any denominator, just 1. Okay, into 2, sorry, 2 into 0 plus 2 by 2, that is, this is 1, and so 2 is here upon 2. Now what will we do here? 1 by 2 plus 1 by 2, that is, this is 3 by 2 upon 2, that is gamma 3 by 4. Here this is minus 1 by 2 plus 1, that is gamma 1 by 4, and this is 2, and this will be as usual. Okay, so because this is not converting in the recurrence relation. Okay, so this is as usual. I will teach you in the furthermore videos of the questions of beta and gamma and how to solve, okay, this gamma function. Okay, so now this is gamma 3 by 4 and gamma 1 by 4 upon 2, simple. And the last question was, that is 0 to pi by 2 sine 5 theta d theta. Simply, I know you all have solved it. Okay, so simple. 5 plus 1 by 2 gamma and cos 0 theta. Okay, cos 0 theta is multiplied, so you can write it cos 0 theta d theta. So 0 plus 1 by 2, again this is 1 by 2, and this is 5 plus 0 plus 2, that is 7 by 2, and this is 2. Okay, clear? So now you can also write it 5 plus 1, that is 6 by 2, that is gamma 3, and this is root pi, and this is 2 into what? How can you write it? 5 by 2 plus 1, so 5 by 2 gamma 5 by 2, and this is what? This is gamma 3, so this is 2 factorial. So 2 factorial is cancelled with 2, so what are we getting? Root pi upon 5 by 2. Similarly, this is 3 by 2 into gamma 3 by 2, so gamma 3 by 2 is 1 by 2 into root pi. Okay, again using the recurrence relation, 1 by 2 into root pi, because n plus 1 is equal to n gamma n. Okay, here n is 5 by 2, so 5 by 2 gamma 5 by 2. Similarly, in gamma 3 by 2, 3 by 1 by 2 gamma 1 by 2, and this is cancelled with this, so these all two will be in numerator, so this is 8 upon 15. Simple. Okay, so this was all about this video. So I will tell you the more questions of beta and gamma relation in the upcoming videos. The question session will be apart from this discussion. Okay, so after that, any proof remaining in this chapter, I will cover this, and the most important thing is duplication formula. So stay tuned, and thank you for staying so long. Okay.